Hello guys, welcome to my YouTube channel Scholar Tech Studio. In this video I will teach you step by step how you can do Adams View MATLAB cosimulation. Let's suppose this is my model that I created in SolidWorks. So now I want to do the simulation in MSC Adams View by considering cosimulation with MATLAB. Okay, so first we have to create the step file of this, or we can create the IGES file of this model. So we will go to save as. Okay, and here we can specify its file type. So in Adams View we can deal with either step file or either we can use the IGES file. So I converted this IGES file of this model and then go to save. So in first step we have created the IGES file. Okay, and now we will open the Adams View. So this is my Adams View. Now we will import this IGES file into Adams View. Okay, so here we will select the new model, and here first we have to specify the directory. So I will select the same folder. So this is my folder, so I select this one. Okay, and now I can specify the model name like crank mechanism, and then we can now the next step is we have to import that IGES file into this system. So we will go to file and then go to import. Okay, so here we have to select the file type. We know that our file is in IGES, so we'll select IGES. So then here we can specify our, here you can see that I save in this folder, so I have to specify the path. So I will select this one. Okay, and then here we have to select the model, and here right click on it, then go to model and guess crank mechanism. Okay, and then we will apply. Okay, now you can see that our IGES file is imported. So from here we can convert it into 3D solid. Okay, so this is our file. Okay, so the next step is first we have to assign the material to these parts, and we can also combine, like when we are going to do the simulation, so we have to use the simplest model. And here you can see that this is the pin. Okay, and this is also a pin, so we can combine this pin with this body, and we can combine this pin with this body, because if we will deal as a separate part, then we have to create we can say a lot of joints, or we can just remove these. If we can create a contact between these two bodies, so we can delete these two parts. So let's suppose I delete this one and then I delete this one. So now I have a simplest model. The first we have to assign the material to all the parts. So just right click on it and then go to modify, and here we can select the geometry and material. So we'll apply the material like steel. Okay, so similarly we'll apply the material to all the parts. I'm going to pause the video. So I have assigned the material to all the parts. So the next step is we have to create the relation, or we have to create different contacts between different parts of this mechanism according to their working condition. The first is that this body must be fixed. Okay, so we will go to contact, and here we will select the fixed joint, and then we will select the ground, and then we will select this base body. Then we have to specify the any corner, and here you can see a small circle. It specify the location of this joint, so I'll select this one. So see, now I have create a fixed joint. Now let's suppose you will go to the simulation. So this way you can check whether all if your geometry is very complicated, then you have to check whether step by whether the material is assigned to all the parts or not, okay, or the contact is created successfully or not. So the best way is that we will do some process and then we will check. Okay, so let me run the simulation. So here you can see that this part is successfully fixed while these parts fall down due to gravity. So now next we have to join this body with this body. So we can see that it's a circular joint. So for that we will go to connect, and then here we will select the revolute joint. Okay, so the first we will select this body. You can select this body or you can just right click on it and then you can select this body, and the second body is this one, crank. Okay, so now we have to specify the location of a revolute joint. So for that, if you will move your cursor, so it specify the location, but we will select the exact center of this circle. So we'll select this one. See, now you can see that this is our revolute joint, and similarly these two parts also have a revolute joint. So we'll select this one. First we will select this crank body and then we will select this body. Okay, and then we also specify the center of this circle. So okay, now it's exactly center. So now you can see that our revolute joint is created. This body and this body also attached with the help of revolute joint. So we will select this slider body and we will select this body, and then we have to specify the circle center. Okay, so one joint is left. This body has relation with this body, but it has a we can say translation joint, so it's move in translation motion. So we will select this body. Okay, so we will select the base, we will select this slider, and now we have to specify the location. Okay, and now we have to specify the orientation. You can see that the arrow direction is showing the direction of translation joint. If I will select this one, then maybe it's vertical, but we must have the translation joint in horizontal to this. Okay, so now you can see that our joints are successfully created. Let's suppose if I run the simulation, see it's rotating because due to its gravity, or we can assign a motion. Okay, before import this model into MSC Adams View, first we create a motion. Okay, so we will go to motion, and here we'll select a circular motion at this joint. Okay, and here we can increase the number of steps. Okay, so here you can see that it's moving. If we decrease the number of steps, then its speed will be like the animation speed will be higher. So here you can see that we have applied the motion at this point. So now you can see that it's moving. Okay, so the next step is we want to import this model into Adams View, so into MATLAB, so that we can control the motion of this crank through MATLAB controller. Okay, so for that first we can say that there is a motor that will rotate this one. Okay, and any controller system that will control the motion of this one. Okay, and we want to know the linear motion of this, like when this will rotate, what will be the motion of this one. So okay, so first we have to create the output variable for this one, for the motion, for the velocity, or for the acceleration. Okay, so for that we will just select this body. Okay, and then this is the slider, and then we will select the measure option. Okay, so here you can see that it's take the center. Okay, so now we have to specify. We can see that this is the x-axis and it's moving in x-axis direction. So here we have to select the x-axis, centimeter position, and here we can specify the name of this. So let's suppose this is our p, this is our p, the position. Oh, okay, and we will set apply. So now you can see that the position is created. And similarly, if we want to check the velocity in the x direction, so here we will select v1 and then apply. So this is the velocity. And similarly, if we want to check the acceleration, so we'll select acceleration, x-axis, and here we will select a1 and set okay. So we have created three things. One is acceleration, velocity, and position of this slider with respect to the rotation of. And now we have to create the state variables. So the next step is to create the state variable. So for this we will go to elements, and here you can see there is a state variable. So here we will specify the name. So we will select input v. Okay, so one variable is input v, apply. The other variable is p, position, we can say p o, we can give any name, position, apply, and then we can say vel, velocity, and then we will apply, and the final is acceleration. So ACC, acceleration, apply, and then we can cancel this. So under the element we can see that we have system variable, or we can say the state variables. One is v input, and there are three variables. Now we need to define these variables. So first we will go to the motion and right click on it, and then go to modify, and here we will click here at three dots, and we erase this. So here we will type var, and then we will put bracket, and then here we have to specify our input signal, that is input slash v. Okay, so here we can verify that the syntax is correct, and then apply OK, and then OK. So now we have assigned this motion as the state variable. Now this variable we can control this variable from the MATLAB, but we have to specify these variables. So for position we right click on it, and then go to modify, okay, and then we will select here, erase this one, and here we will select the measures, right click on it, and here we will guess p. So p is our position. First select this one, and then go to insert object name. So you will see the name is here, and here you can verify syntax is correct, and then you can set OK. And similarly for the velocity, and here we will select OK. For the velocity, go to modify, select here, and then we have to raise this one. So right click on it, and here you will find the v1 is velocity, insert, and OK. Similarly for acceleration, modify, and then we will select measure and a1, okay, and insert and set OK, and then set OK. So now we have successfully defined these variables. Now the next step is we will go to this plugin option, and here you can find the control. So you will click here, and then you will go to plant control. Okay, so click here. So under the plant control, here you can see that there is a input option and there is the output option. The variable, this variable we have created, and the variable that we select input, that variable will take the input from the MATLAB, and output variable that will give the output of any variable. So our input variable, we will just right click on it and then go to variable and then go to guess. So here input v is our input variable, okay, and then our output variable, here we can assign that is position. Just right click on it and then go to velocity and then right click on it and then go to acceleration. So we have 3 output variables and we have 1 input variable. So this variable can be control in, and here control in MATLAB. So here we can specify the name, control plant we can say crank, and we also have to change the name here, crank, crank, okay, and here we have to change the software to MATLAB. So at this, I hope you understand, we have to specify input variable, output variable, and here we have to specify the target software, and we just need to click OK. Okay, it shows that maybe there is some problem with the name position, because there are many other parts that have the same name of position. So we can just change the name, rename, and we can say position slider, and then said okay. So now we have to check our plant. So our control plant is here. Oh, it's update the name, and then we just said okay. So now our setup is prepared. So let me show the window. When you will press OK, you can see here different files. Okay, so now what we have to do in this folder, here you can see that there is a MATLAB file. So we have to open this one, double click on it. Okay, so now you can see that this is the file. We have to run this file, so we will run this one. Okay, so now our file is run, and you can see that all the variables are in here in the workspace. So here we will also type Adams/sys and press enter. So here you can see that this is our input variable, and we have 3 output variables. Okay, so this is the model of crank slider mechanism that we just created, and here you can see that this has only 1 input and has 3 output, and you can see the names. So now we can just open a new simulate model, blank model. Okay, so we can copy this one, copy this, we don't need these two. So this is our blank model, so we'll open this one and we will paste it here. So this is our model. Okay, so we have to double click on it, and here you can see that there is a red box, so we have to double click on it. So here we have to change the batch option to interactive. If you will not select this interactive, then you will get the results, but it will not show the animation of the system. Okay, and if you will select the interactive, then when we will run this model in Simulink, then it will also automatically open the Adams View and will run the animation. Okay, and then set okay. Then here we will go back. Now we have to assign the signal, so we can select sine wave, and then we can specify to this signal. Okay, so you can attach your control system, because you are dealing, this is basically a revolute joint, so you can control this with PID controller, or you can any control system can attach here. So this is this simulation is just about the procedure how you can do. In coming video I will discuss about this option. Okay, so here we can just specify the frequency, radian per second. Okay, the amplitude is 1, so we just said okay. So here we can specify the time. Let's suppose we can select 60. Okay, and then we just need to run the simulation. So it's going to open the Adams View. So now you can see that it's our system is moving. Okay, because I provide a sine wave, so therefore it's moving like left to right and right to left. So it will depend on which type of your control system. See, so here you can see that it's 15% is completed. So I'm going to stop this video. When this simulation will complete, then we will go to the next step. Okay, so our simulation is completed. Okay, now you can see that the position of the crank. So here is the results of the position of the crank, because we applied the sine wave as an input signal, so it's make the sine wave, so it shows that with respect to time it's moving and like reciprocating motion. And similarly we can check the velocity. So this is the velocity, and similarly you can see that the acceleration, or the acceleration of this is changing with respect to time. So this is the complete procedure how you can do the Adams View co-simulation. So I hope you like my video. Please subscribe my YouTube channel so that you can get the notification of my upcoming videos. Thank you.